fun to do. Over the last 20 years, we've watched this internet kick off and go. And we have both Glen Rabenberg and Tom Dykstra doing YouTube videos and TikToking and all that. I don't know if they're TikToking yet, but they're doing the YouTube videos and things like that and have become quite famous. And I feel very honored to know them both as friends, but to have them here today to talk. So we thought it would be kind of fun to maybe do a TikTok filming here at the conference so you guys can all be part of it and see what they go through and what they do to have to put all this stuff together. It won't be quite as intricate as they do at home. But what I'd like you to do is one, I want to introduce them, get them up to the front. So if you guys would stand and welcome Mr. Glen Rabenberg back to the stage. Glen, come on down. And Mr. Tom Dykstra, Dr. Tom Dykstra, come on down. Doesn't matter. Yes, please take your time. The paparazzi will get you.
Hey, nice shades, Doc. Atta baby.
Yeah. They do this in the warehouse when they're filming too, apparently. I didn't know. Have a chair, sir.
Right, thank you.
Welcome to Canada.
Yeah.
Okay, you can take your shades off now. You're kind of scaring me.
I can't see anything.
Yeah.
There's people here.
Yes. Yes, there is. That's good. So you had a good trip up?
No.
No? Okay. Picture this. He's running through the airport to get his flight so he can be here. I'm so proud of you.
Yeah, they gave me the option. You could either show up at 1:30 in the morning or you can run through the airport.
Yeah, I appreciate that.
I ran through the airport.
Yeah, no, that's good. And you just drove, right?
I don't know what the big deal is. You talking about weather to Canadians? Whiner.
There, each one of you guys gets your own mic. They're both turned off, I think. So anyway. So what we're going to do today, Glen and I have put together 3 questions. We haven't told Dr. Dykstra about them yet. So this will be will be quite interesting. We decided to form the questions just because a lot of people don't like standing up in front of the group to ask questions. So I'm kind of using questions that I've had and I would like their opinion on them. And then I know I can copy it and get the answer right. So first question we have, ready?
Maybe.
Are you ready?
I love that scared look, like, oh crap, look in his eye. Because nice work.
I think you're doubling up on me. That's what worries
Well, of
me right
course
now.
we are.
Yes.
This is gonna be so much fun. Okay, let's start out with, remember I asked you about hydrogen that one time? What a hydrogen deficiency looked like?
Yes.
Yeah, wasn't that cool? That was cool.
Yes.
That was very cool. Do you remember that?
I wasn't there when that happened, so no.
Okay,
I
that's
don't
good, that's
remember
good.
that.
Can we ask the group?
Sure.
Does anybody know what a hydrogen deficiency looks like in the soil? Yes, a high pH over 7. You guys are awesome.
Oh, he's gonna spoon feed you. You can see this. Okay, so my next question is, what does a microbe deficiency look like in the soil?
Okay.
Dr. Dykstra, go ahead.
A microbe deficiency is going to be caused by a number of things. One, it's going to be caused by a lack of carbon. It has to, because all life is carbon-based. So if you have a lack of carbon, you will have a lack of microbes. There's no way around it. And because there's no way around it, don't try to get around it. As far as putting things together, though, because everything is grafted together, everything is made of carbon. We are organic beings. It doesn't matter whether it's me or Cindy or Glenn. It doesn't matter. They're all organic based. And because of that, you are going to need carbon. So clearly, if you have a carbon deficiency, you know, he talked about the 8-to-1 ratio, you're not going to have enough life in that. Not only are they just going to be breathing, as he said, but you're not going to have large numbers of them. And there's a big difference between having 200,000 in a spoonful and having 200 million in a spoonful. 200 million can obviously do a lot more for your soil and for your plant. And even though 200,000 sounds like a lot, it is not. Now, the second thing that you are probably going to have a deficiency in, because they go together, is in order to put that carbon together into an organic being, such as a microbe, you're going to need energy. And this energy is going to come from sugar. This is the universal energy source. It is made into 36 ATP if it's operating through oxygen, and that is then going to be able to put together all of the carbon that I just mentioned to you. So in addition to that, you are also going to need a little bit of electricity. It needs to be able to flow. Right now, electricity is going through my body. Right now, electricity is going through Cindy's body.
Easy. He'll lose focus.
I know.
I'm sorry, where was I?
Electricity.
Electricity. Yeah, the electricity thing.
Electricity.
And so therefore, there's going to need to be enough carbon, there's going to be enough sugar, there's going to need to be enough EC in the soil in order to get life, which in this particular case is going to be the microbes. So that's what it looks like to me. I've mentioned 3 things. I wanted to be as short as possible because I wanted Glenn as much time as possible in order to speak, because he gets very upset when I leave him out. Is there a fourth, Cindy?
A fourth what?
A fourth thing that I could do in order to delay Glenn speaking?
Well, could you talk about
Oh, that's a
what
good
the-
one.
what the energy does when there's no microbes?
What the energy does when there's no microbes. Okay, if there are no microbes and there's too much energy flowing through the system, we get electricity. Static electricity, we get burning, we get electrocution. All of this will occur at the root level. All of it will occur above the plant, at the tips of the leaves. And that's what's going to happen if you don't have life, which is buffering, because life buffers everything. It buffers electrically, it buffers pH, it buffers bicarbonates, it buffers everything. You need that ability to have a buffering capacity, otherwise things will get out of control. So thank you, Cindy, for feeding me that fourth thing. We have avoided Glenn speaking for several minutes right now. I'm now running out of things.
Oh, question the bald guy with the visor. Go ahead.
Oh, you're over there. I'm sorry. I
Would
didn't
the
mean to-
EC be a way of checking microbial health and activity?
Yes, it would, because the EC, if it is too high, the microbes get electrocuted. And they're not comfortable in a high EC environment. By the same token, does that mean we need to keep things under control? So we need to keep the EC down? Not necessarily, because when you have low EC, moving microbes, and they're not doing what they're supposed to be doing, which in my particular case is speaking fast. So because of this, you do need the energy. You need some, but not too much. And so that's where this is why we measure EC in the soil, because we're making sure that everybody is happy. We need the microbes happy, we need the plants happy, we even need Glenn happy.
And Glenn's awful happy to ask this next question. Would the refractometer be a measurement of biological or microbiological happiness?
Okay, so the refractometer would not help you at all. So if you're putting dirt into the refractometer, you are not going to get a correct measurement from this. So we're talking about soil microbes. Apparently this escaped the 2 individuals to the left of me. And so no, this is not going to help you. It's not going to give you an accurate measurement. How many times have I discussed this with you?
I am so sorry. What about if you check the bricks of the plant?
Using a refractometer.
Oh, that's different.
I swear to God, I'm going to crack him.
And this is why we're separated right now. Yes, if you measure the bricks of the plant, that will give you a good idea as to how healthy the plant is. Now, if you are going to be measuring it, it is going to have to be through the leaf. I've talked about this in my presentations before. You can measure the stem, you can measure the fruiting structure, such as a strawberry, you can measure the roots as well. But if you want an accurate measurement, something that's not going to be going up and down and is a little bit difficult in order to observe, you really have to measure the leaf. And that's going to give you a more accurate measurement of the health of the plant, which is going to be reflected in the microbes, which is the question that he was getting to right now. I'm getting to it. And that is the plant, if it's healthy, is throwing out more root exudates in order to feed the microbes. And those microbes will pay the plants back. So this is the important part of the soil. I know we talk about soil to the point where it doesn't even mean anything anymore. We've got sandy soil, we have clay soil, we've got loam soil, and I'm checking charts online, and I check a different part. You can go to any part of the country, as you probably know, and find out exactly what the soil is to within a few meters. And so they will tell you that it's not just sandy soil. Sometimes it's sandy loam. What the heck is sandy loam? Well, I guess that would be part sand and part loam, but then you have to figure out exactly what that is. And I'm like, okay, that's all fine and good. I understand it's not that simple, but now you've got what? A 90-10 ratio? 80-20? Is it 50-50? If you have a sandy loam soil, what exactly does that mean? This is why when you learn about soil, please understand, it's not just about the soil. The soil is a relatively dead, relatively inert substance. But when you add the microbes, everything changes. And that's where the action is. And that's the action that Glen was talking about earlier. Action to the point where he almost brought this to a non-family show, and we had to give him an R rating. So when you get this kind of action going on in the soil, this turns around and benefits the soil, and it benefits the plant.
Good job.
Would the consistency of the EC reading as you go through the profile have anything to do with biological activity? Like you say, you take a reading at an inch or 2 inches or 3 inches. If you're biologically controlled, what do you normally see as far as the consistency of the EC meter?
Okay, before I answer that question, I'm going to need to translate for you. So if you go down 2 centimeters, 4 centimeters, 6 centimeters, 8 centimeters,
Sorry.
know your place. You're in Canada, okay? Know your place.
I slid back a little bit.
Yes, you are looking for an EC reading. You would like it to be consistent, but it will not be. The consistency of the EC reading will change due to several factors. One is on one side, on the opposite side of the compaction. Above the compaction, you're going to get a certain EC reading. Below the compaction layer, you're going to get a very different EC reading. And that's going to be the point where life is not doing well. It's not conducive to life. You're always, because of that compaction layer, where sometimes you will actually see a black line if you ever break it down and you take a look at a soil. If you've ever removed soil and gone down, a meter or 2 meters or 3 meters, you notice I used the metric system on that one, right? You following that? Yeah. Then you see that you will find a compaction layer, which will usually be a black layer. It will not be consistent. Sometimes it's thin, especially in our part of the world in Florida. It can be a little bit thicker in other parts, especially if it hasn't been turned over so much, and that's where things collect. So there's a big difference between the top of the compaction layer and the bottom of the compaction layer. To answer his question in a second way, you will always find a difference in the EC reading right around the roots. When you get very close to the roots, suddenly there will be a spike and it will go up. And that's because of the root exudates. The root exudates are putting out sugar. There's usually going to be microbial life, which is going to be very, very close to the roots. That's where they're going to be collecting. And so when you're taking that EC meter and you're testing the soil, sometimes you will get a jump. And that jump means that you hit a root or that you are right next to a root where there will usually be an EC reading, usually, which will either be higher than the surrounding soil such as in Florida, or it may be lower than the surrounding soil if you happen to be in a dangerous high salt environment, because the roots will then regulate something a little bit closer to life. Did I answer it in the way that you wanted, or no? Where were you going with this?
It's all about you guys.
Yeah.
You should ask them if they liked
I-
your answer.
I couldn't even see them when I first walked in. I didn't even know they were there.
The goal here is to help everybody understand how to identify healthy, unhealthy.
I'm here for them.
Give it a shot.
So yeah, defining healthy and unhealthy, I think we're kind of leading in that direction right now. As far as the EC, as far as the bricks, you are looking to see the relative health of what you are growing. Because when you are raising something healthy, it costs less. If you are raising something unhealthy, it costs more. Low bricks farming is expensive. High bricks farming is less expensive. That was a good summary right there, I thought. Yeah.
If a person had a high nitrogen bill, could that possibly be a sign or deficiency of low microbial activity?
Yes, the microbes are getting the nitrogen into the plant. Their job is to collect the nitrogen, which is coming from the soil microbes, the nitrogen fixing bacteria. If they are being fed enough sugar from the root exudates, they will be able to get that nitrogen into the plant, unless it's a low brick situation. Then you don't have enough microbes in the soil, which means they're not feeding your plant, which means you will now have to turn to putting in the high salt nitrogenous fertilizers or other forms of nitrogen that are now out there recently in order to feed the plant. They will need to be there because this is a situation that has been set up for them. Maybe because of something that has happened during the season, or it may be something that you have done over the past 10, 20, or 30 years, where you have now set up a system like a drug addict, where you are now force feeding the plant because the plant cannot feed itself. Are you laughing at my drug addict thing?
Speaking of drug addict, these young fellows here, the college students I got to sit with, we talked about verticillium wilt, Phytophthora, Rhizoctonia, Pythium, fungal diseases.
Pythium is a very large snake. It's a constrictor. It's a little bit smaller than an anaconda.
Python.
Oh, python. I'm so sorry. You're right. You're right.
Have you been off your medication since
different
Sunday?
organisms. Yes.
And here's something that I didn't get to touch on that Dr. Dykstra does a wonderful job on, is the stages of plant growth and the root exudates, talking about pre-reproduction and post. This also affects the microbial community underneath the soil. Could you elaborate on that, Doc?
Sure. There are two phases of a plant: the vegetative phase and the reproductive phase. The vegetative phase is all about, the analogy that I will make is the concrete blocks or bricks, if you want. So if you are making a house or a structure, putting on concrete blocks one after another makes the structure come alive. You see the walls, and it looks like a lot is getting done. And it is getting a lot done, but it's just concrete blocks. So when you are repeating the concrete blocks over and over and over again, that is what happens during the vegetative phase. When the plant is growing roots, when the plant is growing stems, when the plant is growing leaves, this is all that is happening during the vegetative phase. It wants to grow as fast as possible, and we need microbes in order to turn things over. You need a lot of concrete block layers in order to get the job done. And that all changes when you hit reproduction. When you hit reproduction, Now, this is akin to, oh, well, I've got to put a roof on with the roof trusses. I have to put on hurricane strips. That's a Florida joke right there. You have to put in the wiring. You have to put in the drywall. You got to put in the electrical wiring, top, bottom. Everything has to be done. That is complicated. It doesn't really add to the structure that much. It doesn't look like it's adding to the structure, but it's huge in order to build a house. The same thing occurs with a plant. You now have a switch from making constant concrete blocks to now they have to produce a sepal, a petal, anther, stamen. You've now got to produce fruit. You've now got to produce seeds. All of these reproductive structures don't look like they make a huge difference in the size of the plant, but they're massive. They're complex. And because they're complex, they need energy. And they also need a lot of different proteins to put them together. And in order to get this done, you have got to have a switch from vegetative to reproduction. And that switch requires a bump in the EC. You now need more electricity than you did before. Before you needed only a certain amount. Now you need more, whatever that may be, but you now need more. You're also going to need some more sugar because there's a lot more going on. You're going to need a little bit more nitrogen because a lot more proteins are being made. That switch causes the plant to switch its root exudates as well, because the root exudates need to reflect the stage of the plant. And so when you get this switch occurring, a healthy plant will be able to switch over. You don't need to micromanage and control a plant. Saying, oh yes, well, my EC reading right now is coming in at 0.4, so I need to apply something in order to get it up to 0.6 or 0.7. No, you don't need to do that. The plant will take care of it. If it's healthy, it will actually raise the EC level in the roots, in the rhizosphere, and it will take care of it in order to handle the complexity that you and I know as reproduction. Okay?
With that, with the verticillium and the different types of fungal diseases, is there a number on the refractometer that you can achieve sugar content wise to be fairly assured that a fungal, algae, mold, scumbag problem isn't going to cause you ruckus? Is there a number that gives you some security?
Yeah, the numbers usually, when I talk about the numbers, I try to give you a 2 bricks range. I'm going to be no different right now. So if you want to be able to handle the fungus, if you want to be able to handle the molds, you are looking at an 8 to 10 bricks. And 8 to 10 bricks will take care of that situation for you. So I've talked about insects. This is a different matter right now. Now we're talking a little bit more about microbiology, the fungus, the molds, and you are going to need to be between 8 to 10, which includes the number 9, because that's in between 8 and 10. You're welcome. Oh, I'm talking to them. 9 is in between 8 and 10. So when I say 8 to 10, that includes 9. I don't want you to think that just because I left it out, that I have something.
Can we take 2 minutes and put him in the corner and just soften him up a little bit?
We could.
I can hear you. I can hear you. I can still hear you.
Quieter.
I can still hear you.
Next question. If you have beneficial microbial activity and your sugar content goes up to that 8 or 10 brick range, what do you foresee the nitrogen bill being next year compared to what it was this year as you increase microbial activity, EC bricks?
The nitrogen bill will go down unless you are stuck in a rut where you put down the same amount of nitrogen no matter what, because that's the way it's always been. That's what we always do. That's what my dad did. That's what my grandpappy did. And we're just going to continue to put down the same amount. But if you are monitoring, you will notice that you do not need as much nitrogen. I'm talking to you again. You're the one asking the questions. I feel like if I ignore you, you'll cry. And I don't want to do that to you, Glenn.
What's the next topic, Cindy?
So the nitrogen bill is very important. It becomes important not only because we're putting a lot of nitrogen down for our plants, but it becomes doubly important, dare I say, triply important based upon the whole COVID chaos that we just had. When the price of nitrogen went up 3 times and you realized, 1, I can't afford this, or 2, I'm not going to be putting down as much. And some of you have communicated with us before, is that you realized, I put down half as much as I had before, and I did just fine. And that's a sign to you that you didn't need as much of the nitrogenous fertilizers that you were putting down before, which means you can save money. And if this is about reducing inputs, and it is, because I need you to survive. Got a family to feed. I've got 7 kids. I've got 9 mouths to feed right now. So I need you to stay in farming. I need you to be able to feed families like mine. And so because of this, I don't want you going out of business. In order to prevent you from going out of business, we have to reduce your inputs so that you realize what you really need versus what you think you need. Okay, I turned towards them this time and I actually spoke to the crowd. So I actually felt the bond that was occurring.
I telepathically felt a question over here. As the bricks come up and you keep applying the same amount of nitrogen, is it potentially possible to see a tip burn from the nitrogen application, and why?
Yes and no. The reason why it's yes and no is because if you are using a high salt nitrogenous fertilizer, you can raise the conductivity to a slightly dangerous level and you can get tip burn under that situation. If you are using a nitrogen source that is not salt-based, and there are some non-salt-based nitrogenous fertilizers that are out there recently on the market, you will not get tip burn. So the answer is both yes and no. I wanted to qualify that for you so that you understood what causes tip burn and how you might be able to avoid that. I brought the crowd in again. I'm really starting to work the crowd more than I was doing before, and I think there's this awesome
Next
bond.
question, Cindy.
No, it's kind of overdone now.
You give him 1 day off and he's completely off the charts.
Well, the thing is, it wasn't a day off. He was running in the airport.
Yeah.
Yeah, yeah. No, did anybody get pictures of him running in the airport? Nobody?
No
Should we check
pictures.
security, TSA?
Oh, it's all over security. Yeah.
You can see the guards in the back.
TSA
Just,
agents trying to run me down.
Yeah, yeah.
There he is. Catch him.
Okay, so to recap, microbe deficiency, unhealthy plant, low bricks, poor soil or organic matter restructuring or recycling. Would that be an issue?
Well, you just summed everything up right now.
Well, I did.
I've been talking for 20 minutes right now, and you just summed it up in 30 seconds.
Take some lessons. No,
I didn't need to say anything.
no, you did.
All the details were a total waste of time.
No, they weren't.
Total waste
You
of
did
time.
very well.
I'm
Thank
just
you.
going to turn it over to Glenn now. I'm done. I'm so done.
Nobody likes a whiner.
Yeah. Do you guys want to get him something to drink? I'm sure his throat is parched.
Right in front of Greg. Right in front of Greg. We're on
Hey.
the floor. Check the floor. I'll take both.
Okay, second question, and this kind of ties into what you were talking about with the nitrogen fertilizer. Let's talk energy. How can farmers using salt-based energy in the form of nitrogen and phosphates that have a lot of salt in them?
As he's drinking his Mountain
Mountain
Dew,
Dew, yeah.
and we're talking energy,
Yeah,
perfect.
that's all we need is him with more energy. How does a producer move to the point where they can start decreasing the salts that they're using in their salt-based fertilizers to have that energy transfer over to a microbe managed system that will manage the energy? Can you explain the dynamics? Can you explain the dynamics to that?
I'd like to add a question for the doctor.
Okay, go ahead.
A lot of the professors and the academia will talk about soil needs a little salt.
Oops.
The plants need a little bit of salt. And they're right, like they're always partially right, but they're not differentiating between an inorganic salt and an organic salt. So if you're looking to cut back on your commercial fertilizers, there's going to have to be a transition from the inorganic salts to the organic salts. Go.
The organic salts are the salts that are in your body right now. So Glenn made an error earlier on. He said that we're 80% water. We're not 80% water. We're 80% salt water. We don't have as much pure water in us, although we do have some with the whole easy water thing right around where the membranes are. So you know what I'm talking about if you see in the fourth phase of water. But for the most part, we're dealing with salt water, and there is just enough salt in our bodies in order for us to operate, to stay awake, which most of you are doing right now, to be able to listen to me, which most of you are doing right now, and to be able to move around, whether you're moving arms or legs or shimmying or adjusting yourself. These are all energies that can occur when you have the right amount of salt. If you have too much salt in your system, it can mess you up just as much as it can mess up a plant. So when you are dealing with high levels, and you won't know until you test, you got to test. So I just can't look at something. Well, sometimes we can. If you take a look at a field, sometimes you can tell if it's burning. Tip burn is certainly going to be a sign of that. But if you don't know what the EC reading is, you're going to have to find out, because you don't want it too low and you don't want it too high. And because you're looking for that middle region, that comfortable region in order to raise your plants in, you are going to need to measure it. And how far and how fast you're going to be able to do that is how bad a shape you are in. So, Mr. Rabenberg, if you have EC readings coming in at 22,000 or 22, what kind of life would you be expecting under that situation?
Charcoal.
Charcoal? Okay. If we were to bring it down to 15,000 or 15, and the reason why is because the EC readings change if you move the decimal point 3 levels, what kind of success are you going to be able to get from bringing it from 22 all the way down to 15?
15, 1,500, 15,000.
15,000. 15,000 or 15.
We now have embers
Embers, very good.
and
Okay.
smoke.
Smoke.
The smell of burning microbial bodies is eminent in the air.
All right, I got to keep going. All right, I'll keep going. What about 10,000? Or 10?
Ash.
7,000?
Burnt skin.
5,000?
Keep going.
3,000?
You're getting closer.
2,500?
Okay, now what doctor's talking about is the ergs, is the old style. It's in hundreds and thousands. How this relates to the meter that I had yesterday that you guys may have is you move the decimal point 3 places. So 15,000 would be 15.00. Anything over what we've seen in the soil, a 1.1, 1.2, dead. You're dealing with inorganic salts, and you're at the mercy of the fertilizer guy to keep selling you stuff to keep sparking that crop. Is this what you've seen? Getting under 1,000 or getting under a 1.0 is where you start getting the inorganic salts that are created by the microbes, natural microbial energy, and more of a carbon-based plant than a nitrogen-based plant would.
That would be in keeping, yes, getting it below 1. So there was a study I've mentioned in the EC presentation before, which showed that they tried to put as much of the organic, healthy type salts into a test tube as much as they could, and they were not able to get any higher than 1.2. What this shows is that if I see soil coming in at 1.3, and I say to you, well, I know you put down some more inorganic salts, and you tell me, no, I haven't done that. And I say, yes, you have. And they said, no, 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 I haven't. And I say, yes, you have. And I know that you have because I know that this is unnatural. If you're at 1.3, 1.4, 1.5, you've put something down which is unnatural. So obviously we need to be below 1.2, but how much further below? And as Glenn was talking about right now, it's usually the level of 1 or 1,000 that you want to get beneath. These levels are going to change a little bit, whether or not you're in the vegetative phase, which I've said is going to be usually between 0.2 to 0.5 up to 0.6, versus the reproductive phase, which is going to be 0.4, 0.5, 0.8, 0.9. It's going to be a little bit higher, but all of them, whether vegetative or reproductive, are optimally going to be a little bit less than 1. This then begs the question, do all crops respond the same way? No, they do not. Some can handle high EC pretty well and still give you a crop. And that would be right at the top, if you've seen the presentation before, barley. Barley is in the same genus as foxtail. Foxtail is a weed, you all know that, but barley is in the same genus as some of the genera in foxtail. This is a sign for you that if you are dealing with a high EC environment, the only thing that you may be able to do, depending upon how bad it is, to produce a crop to feed your family is going to be barley. If you want a plant that is terrible, horrible at handling EC, the literature is telling me, and now I'm telling you, that green beans cannot handle anything. I mean, we were talking about, yeah, they can go up to 1, 1.1, 1.2, but you are already getting a massive yield reduction when you hit 1, whereas many of the other crops that are out there can do okay at 1 point. It's not preferable, but they're going to do okay. But green beans, they're checking out. They're done. And so we've got crop plants that are all the way in between from the charts that I have produced and that I have seen between barley and green beans and then everything in between. So we do have this variability, and it's good for you guys to know that if you've been raising corn and soybeans and corn forever and ever and ever and ever, and you're having difficulty because of EC, your yields are going down, that sometimes you may need to jump out of your comfort zone. And I have suggested to some saying, look, your EC is too high. Maybe you should raise some barley, give yourself at least a season, maybe 2, and then the barley will help bring it down, assuming that you're not putting down high salt fertilizers. And sometimes I don't know anything about barley. I'm not going to put barley down. And I'd say, well, do you want to feed your family? Because right now, this is probably going to be your best bet, because barley can handle it a little bit hotter than the other plants. And so I'm trying to educate you in a process because I want you to do well. I've already told you, I want you still in business at the end of this year. I want your neighbors still in business at the end of the year. I don't want farmers continually going out of business. And so sometimes these little nuances will help you in order to become a better farmer. And then if you can get it back down, you can go back to your corn soybean rotation.
Not bad.
Yeah.
Better than you thought? Is that what?
6.5.
6.5.
Your side, Tom. I got it. Okay, so in understanding that, how do the microbes buffer control the EC in the soil?
Okay. How do they buffer the EC in the soil? The microbes do this because of their physiology. Because of their physiology and toxicology, which is part of physiology, they are able to hold on to very, very tight levels of, for example, pH. So just to kind of give you an idea of how important this is, your blood There's a very specific pH. If your blood goes up a little bit too much, and I'm not talking 1, I'm talking 0.2, 0.3, it can kill you. If not, put you in the hospital. And blood has the ability to buffer a lot of different things. It is the same thing with microbes. They are live organisms, and they have the ability to buffer because they have enzymes which allow to prevent you from getting too high, and they have enzymes to prevent you from getting too low. So they keep things relatively steady, and because microbes are in a natural environment, they don't like high fluctuations, and therefore they have the ability to buffer everything. EC is just part of it because they can absorb some of the salts and they can actually break the salts down and control them better. How would you control salts? Well, let's take a look at hard water. If you have hard water, which would be high calcium soil, possibly high magnesium soil, how do you take care of that hard water to prevent it from going into your house? You get a water softener. The water softener contains what? It contains a salt. This salt can either be sodium or it can be potassium. And this will help control the hard water that you have going, and it will make it softer. So if you have too much calcium going into your house through the hard water, you can negate it with salt. Now, let's reverse that. If you have too much salt in your soil, I'm going to pull you in just a second right now. So just you're all set. You're ready to go. Okay.
Running.
Then you would put down calcium in order to negate the salt. Do you see how I pulled that in? Man, that was genius. Was this better than a 6.5? This is a lot better than a 6.5.
6.7.
pH, 6.7 pH. Thanks. You guys are so mean to me. And so because of that, I'm teaching just a little bit of chemistry. Know what you can do to take care of your hard water. Some of you know that already because a lot of you right now are usually dealing with hard water because a lot of you are farmers and you're out in the middle of nowhere. I'm on well water as well, and I have a lot of calcium problems too. And so there are ways to take care of that. So I need you to be aware of that. Not only can you take care of your hard water, but I wanted to extrapolate this for you so that you understand what you can do if you have too much salt. Because there is a wonder drug. I'm bringing in the drug thing again. There is a wonder drug out there called GSR calcium. I have no idea what GSR stands for, so we'll just call it GSR. Okay? So when you have GSR calcium.
Glen's secret recipe.
20 years. I finally found out. Wow.
So if you get a hold of some of this calcium, you'll be able to negate the excess salts and you'll be able to speed the process up. Because normally the soil will take care of the salt over time, but who wants to wait several years for that to happen? Whereas a good calcium source, such as the Glen's secret recipe calcium, will be able to speed the process up and will reduce your salts and get your plants getting back into that healthful mode that we are alluding to right now. Glen's secret recipe.
I know, hey?
Can I touch on EC on water?
Yeah, for sure.
Anybody check the ECs of the water that you drink for yourself and that you also mix nutrients with? Yes. The pure water is water being H2O. The lower the conductivity you will have on this meter. If you can have water that is a 0.00, it's perfect. That's distilled, that's RO, that's deionized. The higher the number, the more electricity and the tougher it's going to be to keep nutrients viable and available in that high electrical solution. So in most cases, if your water is a 0.3 or below, you're going to get pretty good availability. No way.
Yes, way.
What'd you put in there?
Oh, Redmond salt.
This tested 3.44. The plastic is starting to melt.
Zero. Zero.
Okay.
See?
The normal water, this is wherever you bought this water, Cindy, it's wonderful. It's pure. Some people will say drink high conductivity water because that will energize you. What we have learned and what we have found, plants, animals, humans need, appreciate, and enjoy low conductivity water so it can pick up impurities in your body, in the plant, and flush things out. The reason I'm bringing this up is a lot of the California West Coast farmers we deal with have horrible, horrible water. And if you don't know what your water is, you may be leaving money on the table using a water that's tying something up. Possibly get some rainwater, something like that, because rainwater will be 0.00. RO water, distilled water, reverse osmosis, as well as deionized water. So please, 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 for your own health and for the economics of your farm, check to see what water you're using for your foliars, your sprays, and your starters.
That's a very good point. Years ago, it wasn't hard to find good water in Saskatchewan, Manitoba. You could go to your dugouts, you could go to your wells. The TDS was quite low, the sulfates were low, the bicarbonates were low. The last, I don't know, 2, 3, 4 years, that's becoming a challenge. So one of the things too, when you're starting to mix, make sure you're getting a good water sample and make sure the bicarbs and the sulfates are at least 100 or less, I would say. And the lower the TDS, the better. So it's not an easy feat finding good water anymore.
I thought that you were supposed to drink high conductivity water. I'm confused here. So what you're saying is, if you're in a raft in the middle of the ocean, you shouldn't drink seawater? Is that what you're saying?
I've never been on a raft.
I have never been told this before. This is just weird stuff right
Did you
now.
listen to anything that I said about zero is the best water to drink for cleansing, purifying, detoxifying, and healthing something up, I think is how you term it?
So that means I'm going to die of water deprivation in the middle of the ocean, surrounded by all of that water. That's what you're trying to tell me right now.
Dying from dehydration while drowning in salt water. Can we do an EC on that Mountain Dew, Cindy?
I was thinking an alcohol check or something.
We need a screening or a urine sample or something.
He has referenced drugs quite a bit. Yeah. Good. Great. Everybody understand that?
Anybody want to go out in the middle of the ocean right now on a raft? No? No? Anyone? Anyone?
Everybody.
All right.
Yeah.
Yeah. There's always one.
Always.
Always one. Yeah.
If the EC of the water is high, if the EC of the water is high, is there anything which we can do to lower it?
Well, I just mentioned calcium. I just mentioned calcium as being one of the things that you can do. So if you do have high EC water, such as a well, could you treat it with Glen's Secret Recipe calcium? Well, I don't know. I don't even know who to ask. Would you be able to treat a well that, high EC, problem water? Would you be able to treat it with some of your Secret Recipe calcium? Is that something that you could do for the benefit of a farmer?
We need to know if we bring a knife or a gun to the fight. What mineral are you thinking of? To clean out of the water, to lower the EC.
Trick question.
Calcium. The calcium, you said?
Well, the thing of it is,
Carbon.
if you have high bicarbonates, you can use sugar. You can use a humate. You can use humic. Because a bicarbonate needs carbon, and that will also drop the pH. So if you have a high bicarbon, nothing else, just high bicarbs in your water, add sugar, the sugar will hook into the bicarbonate and it'll drop the pH and you'll have pretty decent water. That's only if you have bicarbs by itself. If you have terrible water, you may need an RO system. You may need some sort of filtration. But the first thing is to check what you have first. There's too many variables to go in. We could talk for 3 hours and not touch on half of them. But find out what you're fighting first, and then take a look to see what your best option for that is. But many times just filtration will help with that.
Okay. All right, we got that one out of the way. Third question. Ready?
Yes.
Give it to him.
Okay, okay.
This is total setup. I have no idea where this is
You
going.
don't know what's next.
Total setup.
Exactly. Next time, get here on time. You won't be left out. I've gotten.
I ran for you.
I know
ran
you
through
did.
the
I know,
airport
and when
for
I
you.
heard that, my heart cracked a little. Not a lot, but it
Just-
did.
yeah, just a
the
little
ice.
bit, yeah.
It's cold outside.
Yes.
Yeah. Anyway.
Yes.
Okay. I've been getting a lot of questions about for our livestock guys. Using GMO corn, BT corn modification, that kind of stuff. Wanting to know why they should change and what effect these plants have on soil health when they're being recycled back into the soil and gut health. Should you care to comment?
I would care to comment on that.
Nice question.
I know, wasn't that? You did well, Glenn. Thanks for giving that one to me.
They are ganging up right now. I don't like the way this is going. I need some help. Can someone just stand by my side while I answer these questions?
I got your back, pal.
Moral
Go
support,
ahead. Just
moral support.
don't worry about a thing.
When you are using a GMO product, and I'm going to talk about, we'll talk about the cry proteins right now, okay? So if you have a cry protein, single stack, double stack, triple stack, I really don't care. You are producing the cry proteins in every single cell of the plant. So if you are going after the corn earworm and you have a cry protein to take care of that, it only really needs to affect the ear. But the entire plant is filled with these cry proteins. If you're going after the European corn borer, it's usually in the stem, but every single cell is producing that cry protein. If you're going after Diabrodica, corn rootworm, you're going to have cry proteins that are being produced in order to take out Diabrodica. And there's several different species of Diabrodica, I know. But the fact is, every single cell is producing it. When every single cell is producing these cry proteins by design, is genetically modified by design so that it becomes resistant to the corn earworm, European corn borer, corn rootworm, whatever it is. When you are producing that much protein, the corn plant gets tired. A tired plant is not photosynthesizing well. A tired plant is not making a lot of sugar. Tired plant is not putting a lot of root exudates into the soil. This weakened plant is now going to adversely affect the microbes. I believe that was a question, had to do with the microbes, yes. So because of that, we have now complicated the microbial situation. We have attacked the microbes, not directly, but indirectly. We have attacked the microbes by making a plant tired. And it has to be tired. If you don't understand how exhausting it is to produce the same protein in excess, then maybe you don't understand what happens when you get sick. Because every time you get sick, your body goes into massive protein production and you start producing white blood cells. And those numbers will go up, not a little bit, but a lot. And what happens? Every single person in this room knows exactly what happens to you when you get sick. you get tired and you want to go to bed. You can't even keep your body heat up. And so you pull the covers up. You're cold, you're tired, you go to bed. We are producing tired plants, cold plants, so to speak, that want to go to bed. And we are asking them to produce a corn ear. So this is the problem that is going on. And because we aren't putting enough carbon from the sugar source, we're not putting enough carbon into the soil because of a weakened plant. What is the result of it? We get less sugar in the soil. Season after season after season. And when you go through these plants that are genetically modified using the proteins, especially if they're triple stacked and beyond, then you are dealing with a lot of proteins that are being made in every single cell of the plant. These weakened plants do not serve you well in the long run. They will continually weaken the soil because there's not enough carbon going into the soil. If you have a high Brix plant coming in at 16 Brix, there's a lot of carbon going into the soil. If you have a low Brix plant coming in at 3 or 4 Brix, there's very little sugar going into the soil. And as you do this season after season after season, you will find it's getting harder and harder to raise corn. I don't understand what the problem is. How do you handle this? Oh, I know. Your inputs go up because your plants aren't doing well. And because they're not doing well, they're going to need more money in order to raise the plants. This is what GMOs are doing. If you look and perceive that the insect is the problem, then you're never going to be able to break out of that. And you will finish your farming career constantly going after the insects, trying to kill them because they are the problem. However, if you view insects as not the problem, but as an indicator, they are now indicating to you that there is an unhealthy situation and that you should probably do something about it. That's what it's indicating to you. The answer is not to start feeding at high input costs because that's not helping you. Who is that helping? That's helping the big companies. That's what it's helping. And by the way, they're doing very well. These companies, and I'm talking, you know what companies I'm referring to, the ones that are making between 30 to 80 billion dollars a year in profits. I'm not talking multi-million dollar companies. I'm talking about billion-dollar companies. They are posting, I've checked the data, get on the internet. They're still posting profits. Let me ask you this question, rhetorical question. Farmers, how are you doing? Are your profits going up as much as those big companies? Because I'm pretty sure it's not. And so this is the problem that the question is posing right now. You have now been fed information, incorrect information. I am correcting it right now. It hurts me because every time I say this to a big group like this, I know that not everyone is going to either believe me or accept this information and make a change. But I do have the satisfaction of knowing that some of you will. And so this is the reason why I run through airports. That was definitely a 7. I'm way above 6.7 right now. I'm way above 6.7.
7.3.
7.3?
Yeah.
Man, you're killing me.
Well, you still have another hour and 10 minutes.
I had a lot of information. I had drama. I was connecting with them.
That's right. I found, okay, 7.5.
Oh, thank you. Thanks.
He missed his squad.
But he fell over. That was a terrible dismount. 8.5. All right. Yeah. Thank you. Thank you. Thank you very much.
All right. So, Lauren, we're 10:30. Are you break for coffee now? Is that half an hour?
How much damage can you do in half an hour?
Should we field some questions from the floor? Are you ready?
Yeah.
All right.
Has anybody come up with a question for Dr. Dykstra since he wasn't here yesterday to participate and give information? I think somebody should have something.
I would think so.
Alternatively, there may
Okay.
be people who have a question for Mr. Rabenberg.
All right, Leo.
Well, if you take your mic out and go and find somebody for a Glen question.
Talking about pHing water for spraying. Years ago, talked to Mr. Huber and Mr. Stoller, and they were talking about pHing your water for crop spraying down to about 5, something in there. And I've got some customers, very big customers, and they're pHing their water for glyphosate down to 3. Does that make any sense?
When you are spraying a solution onto a plant, the pH is going to make some difference, but not a lot. In other words, you have the dilution factor. So when you're putting down a 3 pH, a 4 pH, a 5 pH solution, and you're putting it down into, let's say, soil, which is coming in around 6, there is not going to be it's not as if it's even, as if you put something in there at 4 and your soil is at 6, that the pH ends up at 5. You're going to have a dilution factor. The amount that you are putting down is going to be making a very, very small difference. It might go from 6.4 to 6.3, probably no more than 6.2. You don't get much of a difference. I don't consider the changes that occur when you put down a low pH solution to be problematic. Now, why are they suggesting this, or some people suggesting? This has to do with stability. This has to do with stability. So just like we put in high salt and then high nitrogen fertilizers to stabilize it, we also many times will lower the pH in order to stabilize the product so that it can survive long term. So that's some of the games that we play. But I can see, based upon the look on your face right now, that you have a follow-up question. So I'm going to stop talking right now and allow you to ask that follow-up question.
So we're starting off with pHs of water of like 7, 8, 8, 2. And one thing I noticed when reading some of the GSR calcium and things like that, that if they have a little bit of a problem mixing with the products, that it suggests in the literature that they lower the pH.
Okay, now you're talking about GSR calcium. So Glenn, I'm going to defer to you about the effect that this is having, because he's talking about the order of mixing, and I know that you've got a certain order of mixing that is necessary. So I'm trying to divert.
Whenever you're mixing anything, the cleaner your water is, the lower the EC that it is, the better it will go into suspension.
Uh-oh.
One of the things with calcium, sometimes you'd like to put something into suspension
Sure.
or even into solution,
That too.
but can't.
No.
Good calcium will never go into solution.
That is good. Could you repeat that?
It will go into suspension
That's not what I said.
with agitation. Now, the other thing, and looking at this, rather than the pH of the water, has anybody ever put a pound of sugar or a humic acid or a humate with the chemical?
Is that a rhetorical question, or you're just a? Oh, you are actually asking the group. I'm sorry.
What would
You're doing
happen?
great.
What would happen if you'd put a carbon with with the chemical? Has anybody played with that? Adding sugar, good, bad? I can't recommend this because it's off label and nobody will probably recommend this, but we have heard people putting a pound or two of some kind of a carbon or a humic or a humate or some kind of a carbon and increasing the kill of a chemical while decreasing the stress on the plant. Anybody ever use Cobra on soybeans? It's a late season herbicide. It's a wonderful herbicide, but it absolutely beats the snot out of the plant. We had two guys spray the exact same day. One guy used a pound of sugar with it, one guy didn't. 7 days later, without the sugar, the plant looked like it just got kicked right in the plums. 2 days after the sugar herbicide was applied, it's like nothing happened. You didn't hear it from me. I am not recommending this, but we have seen a lot of people do wonderful things experimenting with adding carbon if you need a chemical. And people say, why is that? Because the carbon is what makes up the plant. This carbon, oxygen, and hydrogen, and and you're giving the plant what it's deficient in because you're needing the chemical. And so, what we're looking at here, he got too much sleep. But play with that, and these are tips that you can try on your own that will save you money, that will make you money. And do you have any follow up with that, doctor?
Yes. A cobra is related to a python. So
Any other questions from the crowd?
no, he was making a good point about the carbon. When you are putting carbon with some of these pesticides, especially, you can actually increase its effectiveness. And so for those who have tried it before, they have been able to achieve increase in kills by putting sugar in with various pesticides. The amounts vary and the successes vary, but many people have had a chance to reduce it and still doing well. So when Glen is referring to the addition of carbon and the health benefits that, there goes my seat, the health benefits that come from it, this is kind of what has been alluded to. Some people have tried this on their own and achieved great success with it. So please understand the importance of carbon, whether it be sugar or whether it be other sources of carbon that are out there. A lot of them are very effective.
Would increased bricks or high sugar, could that be construed as a natural fungicide?
That would, because now you're having more root exudates going into the soil, healthing up the system, therefore making it more resistant to disease.
Would a higher sugar content be a natural insecticide?
Yes, it would. And the reason why it would is
Tell me a
because
story.
I want a toy gun and I want peace in the world.
Let's talk about insects.
Oh, insects. If we're talking about insects, when you are talking about insects, you want an insect that is not happy. A not happy insect is going to be a Hybrix plant. They don't like the Hybrix plants. So if you are dealing with a healthful situation, increasing the carbon, then you will have unhappy insects. The bricks will go up and the insects are no longer interested. Or if they're not interested, another insect will come in, because we have certain grades of insects that I've talked about before, and they will come in based upon certain bricks levels and take out the plant. Why? Because it's not supposed to be there. How do I know that it's not supposed to be there? I've talked about this before too. If you have crop plants, I've measured about 80% of the crop plants that I have measured, 80%, not all of them, are between 2 to 10 bricks, 80%. If I measure other plants, which include over 95% of the plants on planet Earth, a tree out in the middle of nowhere, I go to a forest, I just got a plant growing. I don't care where it is, but if you're taking a look at those other plants, 80% of the time, they will be between 8 to 18 bricks. And the reason why we just don't see a lot of plants below 8 bricks in nature. Why? Because they get picked off. They get picked off by insects. They get picked off by fungi. And the only way to keep something below 8 bricks in nature, in nature, it won't happen in nature. To do it is to actually protect it. We need to put protectants down. Those protectants are insecticides, fungicides, things like that. They are designed to protect the plant because it's not able to defend itself. This is why there is such a disparity between most of the plants on planet Earth, which are between 8 and 18, and then the difference that we're getting with many of our crop plants, which we are spending a lot of money trying to raise and not doing the most successful job. Not because this is your fault, but because it's other people's fault.
Speaking of faults, have you ever seen a weed of any sort, a disease of any kind, or an insect of any certain species be able to survive high bricks? Above 15 or 16 bricks. Oh, I got him thinking.
I like asking questions.
Kind of,
and
sort
something.
of, no. But some people consider epiphytes to be a type of weed. So if you come down to Florida, you can come visit me anytime you want. You just come. It's much warmer down there. You really enjoy it. Yeah. Then we do have Spanish moss, and the Spanish moss can be associated with healthy trees, and so I guess not. But generally speaking, the answer is no, because healthy soil has got a lot of root exudates, and healthy soil is not conducive to weeds, because weeds are there in order to correct a problem, and so you won't find a lot of weeds out in nature, and so you do not find the insects at all at 15, 16 bricks. They're not interested in eating the plant. The only time you'll see an insect on those plants is when they simply land on it. So if you have a 16 bricks plant and you watch a dragonfly and then it goes and lands on your plant, don't take a picture of it and like, aha, see, and there's an insect. It's a dragonfly, stupid, okay? Don't tell me that dragonfly is going to start eating the plant right now. It's just resting. That's all it's doing. It's just resting. They're carnivorous, by the way, if you don't know that. Dragonflies are all carnivorous. So because of that, no, that doesn't count. So if they're resting on a plant, that's one thing. Sometimes when the bricks goes down, 12 bricks, that's the point where some insects will go up and take a bite. They're going to try things out. So I get the photos. You said 12 bricks. They're not going to touch it. See, I've got them eat. See, here's the leaf right there. See the leaf? It was eaten out of. Do you see it was eaten out of? Yep. And I can see that it was eaten out of. But they stopped eating. They stopped. They tried it. They weren't interested. They moved on. But this is not happening with the 15 bricks that Mr. Rabenberg was talking about. This is when you start to get a little lower. They're going to try some things out. And if they like it, they'll eat the entire leaf. If not, they're going to move on. And as far as fungus is concerned, fungus will not take hold of a plant that is at 15 or 16 bricks. This is why over 95% of the plants on planet Earth don't have fungus attacking them. They don't. Go ahead, look for it. You don't see most of the plants being attacked by fungus. Sometimes they do. They have to be weakened in some sort of way. For example, the leafcutter ants, they will go ahead and masticate it, and they can go ahead and play games, and they can get fungus to grow on it. That has been brought up before, too. I'm just going to nip that one in the bud right now, because everyone likes to think of exceptions, especially some people who have a lot to lose from what I'm saying right now. Is that good?
That's perfect.
How good? Like, like
Okay,
super good?
You jumped. You're up there. Yes, yes. You're doing well. You're doing well. You spell it 9-4?
What? 6-6.
Did you?
Do we have time for any other questions?
We do, yes. One more question. And Boy, he's agile. Oh,
He is.
that's crazy.
I got a question about EC and foliar application. I tested mine last year and it was around 3,400, and I decided to try some C90 salt in there just a little bit to see what it would do, and it shot above 10,000 with just a little bit. Is that a good thing or a bad thing?
The sea salt that you refer to is generally a very beneficial product to put on plants, and there have been a lot of successes that come from the sea salt. But you just said something critical, and I want to emphasize that right now. You just put a little bit. So this is not about going to the ocean, filling up a tanker truck, and putting sea salt, seawater, on everything right now. This is not how it works. A little bit goes a long way, and this is partly because there are a lot of micronutrients in the sea. So that's where that comes from. So a little bit does go a long way. Now, putting it on, that is not a bad thing because of the dilution factor that I referred to before. So when you're putting on something that is relatively hot, it is not as big of a problem. However, it can be if you are doing a foliar spray, because it can burn the leaf. Most of the nutrients do need to go into the soil and be taken up into the plant through the root system. Go ahead.
What I did was a 50-pound bag and an 800-gallon sprayer mix. So I thought that was a little bit. Is that little or is that a lot?
I don't know. What did it
Okay.
measure? You
Well,
said
it was 3,400 before and 10,000. Well, my meter only goes to 10,000, and it was at least that high.
Yeah, 10,000 is very high. If you spray that solution on your leaves and they burn, you went too high. So
They didn't burn.
okay.
There's no sign of burning at all.
Okay, fantastic then. Fantastic. Then I would say you're going to be just fine with that. Even though that does strike you as being high, you're not putting that much down. So yeah, I mean, 800 gallons sounds like a lot, and there's a large dilution factor. So I wouldn't worry about it then. If the plants are telling you, I'm good, then they're good.
Any other questions?
For Mr. Rabenberg.
It's going to be for you, Doc.
No, it won't.
In a situation like the gentleman here, would it be correct to say maybe take a Brix reading before you sprayed and then say a day or two after you sprayed to see if that has any effect to the Brix reading?
Good question.
Yeah, I was talking about testing and how important testing is. If you are testing before the application and then after, this will also give you. So I just mentioned, take a look at the leaf. Is it burning? You put too much on. If your Brix is coming in at 5.2, and then you put on an application of whatever it is, I don't care what it is, and then you measure it, and you can do it pretty quick, by the way. You can do it within 24 hours, sometimes less. But 24 hours later, you do a measurement and it comes in at 5.2. Did it do anything? Well, no, it really didn't do anything. But the good news is it might not have done anything bad, because if the Brix goes down, which it often does when you're putting on a pesticide, which it often does when you're putting on a high salt nitrogenous fertilizer, that is an indication that the plant doesn't like it. But if the Brix goes up, and when I say up, it is very rare, but it's very exciting when a product, whatever the product is, goes up 2 Brix. I'm usually looking at a jump of 0.5 Brix within 24 hours. That's an indication to me that, okay, this product, whatever it is, make up your product, whatever it is, seems to have a beneficial effect upon the plant. But anytime I get a jump of 2 Brix, that's considered to be really good, really excessive. On the other hand, do be careful though, because when you are dealing with a 3.9 Brix plant, going up 2 Brix, it's not that hard. If you are dealing with a 16 Brix plant, you ain't going up 2 Brix. It is not easy to go from 16 up to 18 because you've already arrived when you're at 16. So pay attention to the numbers too. A lower number is going to be easier to raise up. because it's very unhealthy. That's why when you give medication to someone who's sick, they can respond immediately because they need help. And so if your plant needs help, there are a number of inputs that you can do to make it healthier. Because once you get a healthy plant, your costs will go down.
On the EC of your sprays, Greg Moline has done a lot of work with this. The more inputs that you have in that solution, they may all add a certain vibrational frequency or electricity. The more ingredients that you have that are adding to the electricity or to the EC, normally the higher the level of EC you can get by with. So if you had 9,000 or 10,000 ergs or a 9.0 or a 10.0 on this, just from straight sodium chloride salt, it would burn the dog crap out of that plant. If you had that same number from a little sugar, a little fish, a little seaweed, a little soft rock, some microbes, the more ingredients you add, possibly some raw milk, that will be a nice massaging foliar application. So it's based on what goes in, how many inputs make up that number, as well as how high the number is.
Perfect. Oh, all right. Well, thank you guys. That was kind of fun, kind of different. We'll see how the responses go. I guess I should turn on a mic. That makes it sense.
Oh, we can hear you now.
You can now. Yeah,
Yeah.
that's good. Anyway, thank you guys very much for participating. It was Dr. Dykstra's idea, but we went along with it anyway. So anyway, thanks. We'll give you guys a break for a few minutes and we'll get you back in about 15 to talk about spider mites. So
Okay.
thank you so much.